Yes, good morning. Am I audible? Hello.
हॅलो गुड मॉर्निंग सर. परवा आपला ड्राईव्ह झालता एकाचं शॉर्ट लिस्टिंग झालतं, त्याचा थोडासा मेल पाहिजे होता मला.
Hello. Yeah. Am I audible?
Yes, sir.
Okay. Right. So how many joined? 37. And I have started the recording, so you can write your roll numbers in the chat box now. Write your roll numbers in the chat box so that your attendance will be marked. Abhilasha Kale, Aishwarya, then Vikram More. Still this one also. Roll number 1. Renuka. Still your names are not as per format specified by us. So check what others have written in place of their name. We have decided to go for ECA dash roll number space your name. This is the format we have specified, and still your names are not there in a format. So get it corrected. Yeah, check whether the screen is visible.
Yes, sir.
Okay, so in the last lecture we were discussing about different components of IoT system. In that, first component is embedded system that we have discussed, right? So this is the embedded system which we have discussed in last lecture. After that, we have studied what exactly things are there in the embedded system, which is actually hardware and software, combination of hardware and software designed to perform some specific task, right? So we will keep on talking on this embedded system later on in the second unit, because this second unit is completely based on embedded system and the different softwares that we need to know and different hardware that we should understand. So everything will be discussed in second unit, right? So this sensor part, right? So this is also discussed in last lecture. Different components of IoT system. In that, second component is sensors, and there are different types, such as analog and digital. So the sensors who produce output in analogous form, it will be treated as analog sensor, and the sensors which produce the output in digital form, they are called as a digital sensors. So if you want to give some examples, analog sensors are like PT100, then thermocouple, thermistor, right? And if you change some physical parameter like LVDT is another analog sensor. Then for digital sensors, the sensors which produce digital output, right? So rotary shaft encoder is one of the. Then optical sensors, they produce the pulse high and pulse low, right? This form of output they produce. So these are also kind of digital sensors, right? So in short, sensors are electronic devices that sense the physical environment. And industrial automations, in industrial systems, this robotic system has multiple smart sensors, right? And sensors, they can be sensors and actuator, they work in pairs actually, right? A smart sensor include computing and communication circuit, computing and communication capabilities, right? So this is another field of research actually. Smart sensors, त्यांची काय capability असणार आहे, they can compute, they sense basically, they compute and they communicate. So the things are being sensed, then analysis is done at the sensor itself, and then they send the data to the this hardware part. Like let's say if we are having controller, right? So the controller will receive the input from sensor. So this is what sensor is. Then in internet of street lights, or each street light will be having some this population density type of sensors. We, one of the example we have discussed, like traffic signaling, in which if you want to implement that idea, you will need the sensor. So sensor will detect the user density, and based on user density, the amount of time or the duration of time will be decided based on the density of that road traffic. So on suppose on some lane, the traffic density is more, population density is more, so the signal will be opened for more amount of time. And if some lane is having low traffic, that can be detected by a population density sensor, and then it is fed to the control unit, and it will decide to open that signal, open that or turn the signal green for small duration of time. This is how the things work actually. So digital sensors, analog sensors are basically the types. Next is communication system. Now, this was the part where we stopped in last lecture. So, communication system, actually, we were discussing a couple of types. So, can someone tell me what types we have discussed and what types are remaining? Yeah, what are the types of communication system? Can someone tell what are the types of communication system?
Serial and parallel.
Okay, good. Serial and parallel. Anything else?
Wired and wireless.
Wired and wireless, correct? Very nice. Anything else? Okay. So this communication system is broadly divided into two basic groups. One is serial and second one is parallel. Right. So in those two categories, if you consider those two categories, right? So if you compare those two categories, we know that parallel means a byte of data. Let's say if it is 8-bit communication, a byte of data will be transferred from one end to another end with one tick of time, with a single clock pulse, right? So for that, if I want to transfer 8-bit data from one place to another place, uh, in a parallel communication mode, what will happen? I need 8 lines, 8 pins, and on all those 8 pins, we will send the complete byte of data with single clock pulse. Right. So this will happen with parallel communication. But what will happen if the distance between transmitter and receiver is more? In that case, it is very complicated to have those 8 lines from transmitter to receiver, right? Of course, the parallel communication is fastest communication, but whenever we are dealing with long range communication, we should prefer serial communication because it requires a single line to transmit the data and another line to receive the data. So only two wires are sufficient to carry the complete data. Let it be 8-bit or 16-bit or 32-bit or 64-bit or 128-bit. So no matter how long the data bits are, but serial communication is very effective way of transfer of data, which is cost effective solution. Let's say if we consider, if you tolerate the delay amount of delay required to transfer the data, you can prefer the serial communication, right? Now, after that, we taken two things into the consideration. One is wired communication. Second one is wireless communication. So, as far as their names imply, wired communication means what? There involved a wire, and just now I told you parallel and serial communication with reference to this wired communication. So if the distance between transmitter and receiver is less, you are preferring parallel communication, right? And you can have the wires between those transmitter and receivers, right? So serial, for long range communication, we prefer the serial communication. Let it be wired or wireless. Now, the thing is wireless. If I talk about this wireless communication, what does it mean? This is first thing. Second thing, which one we should prefer, which mode of communication we should prefer, whether serial or parallel. This was the question I have asked in last lecture, right? So let us talk on this wireless. So no wire will be involved in the process. No wire will be involved in the process. Now, in this particular communication system, do we prefer parallel or serial mode of transfer? Somebody rightly mentioned yesterday, in wireless communication, serial mode of communication is always preferred. Let me tell you why. When we talk about this wireless communication, and if you adopt this parallel thing, that means your transmitter is sending a complete byte of data at a time to the receiver. That means your D0 bit, D1 bit, D2, D3, so on up to D7. All those bits will be transmitted by transmitter with single tick of time, and it will be received at receiver, right? So D0, there may be a chance to go in a D3. Your D1 bit may go to D5. Your D2 bit may go to D7, right? So these are the situations where crosstalk may happen. So where the crosstalk may happen, and because of which errors will be present in parallel communication as far as wireless data transfer is concerned. So For wireless communication, always there will be a serial mode of data transfer. म्हणजे जिथं wireless communication आहे, let it be your mobile phone or laptop, Wi-Fi, Bluetooth, Zigbee, RFID, all of them are working on those two principles. If it is wireless, it will be serial, it will be using serial data transfer. Now let us focus on this one. Right. So how many types of serial communication that you know? Some of the examples I have given you in the last lecture. So let me start with basic thing, UART. What do you mean by UART? You might have studied this UART. What is the long form of UART? Universal Asynchronous Receiver Transmitter, right? So if I show you some UART communication protocol, these are basically a protocols. UART. Right? So this is a good example of UART actually. Yeah, this one. Hope you are able to say this. Now, there are two devices, UART1 and UART2, right? So this may be a microprocessor, controller, or let's say peak microcontroller, or it may be of any bit processing. Means it may be 4-bit, it may be 8-bit, 32-bit, 64-bit, or 128-bit. So whenever two devices are communicating with each other by using this UART communication, it will have two pins. It will have two predefined pins. One is called as TX, another one is called as RX. Use of TX is to transmit the data, use of RX is to receive the data. So one device will transmit the data on TX pin, another device will receive that data on RX pin. You can observe it here. UART1 makes use of TX pin to transmit the data, and at the same time UART2 is receiving the same thing on RX pin. Similarly, if opposite way, UART2 is transmitting data on TX and UART1 will receive it on RX pin. So this is simplified block diagram of UART. I hope you remember this one. So TX is used to transmit data, RX is used to receive the data. This is simplified UART diagram. Next one is, can someone tell? Can someone guess what is next?
USART.
Correct. USART. So if I show you this USART, okay, it can be visible here. I hope this is visible. Now, this USART will have a master and slave kind of structure. Means both the devices cannot work as a master. So one of them have to be a slave device. Now, what is difference between master and slave? Are they same or they are different? This is my basic question. You might have heard those two words, master and slave. Are they same or they are different? in the communication system, you might have seen those two devices, master device and slave device. My question is, are they same or they may be different? Okay, let me answer. Basically, master and slave devices belongs to the same category. Initially, the name is used as like a client. One of them will be designated as a master, right? सो जसं तुमच्या क्लासमधून एखाद्यालाच आपण कोणीतरी म्हणतो क्लास रिप्रेझेंटेटिव्ह सीआर, right? So CR belongs to the same category of student, right? So this is how master and slave works here. Master, it can be a device which is selected from slave devices. Now the basic difference or the distinguishing point between slave and master is master always initialize the communication. Master always share the clock. ठीक आहे. समजा एक मास्टर डिव्हाइस आहे आणि त्याच्यासोबत कनेक्टेड 10 स्लेव्ह डिव्हाइसेस असतील, तर क्लॉक कोणाचा यूज करायचा? आपण क्लॉक ज्याचा यूज करेल त्याला आपण मास्टर म्हणायचं. समजतंय? So the one who will share the clock will be referred as a master device, and who initiate the communication is called as a master device. So here you can see this UART communication. In UART communication, it is very much similar to the one which we have studied, one which we have seen just now, that is UART. The transmitter will transmit the data on TX pin, receiver will receive the data will be received on RX pin. But the thing is, clock. Why clock is required? Just to have the synchronization between data transfer. Synchronization म्हणजे काय? Can anyone tell? What is the difference between UART and UART? बघा, UART मध्ये सिंक्रोनायझेशन नसतं. म्हणजेच काय की मास्टर हा डेटा ट्रान्समिट करत राहतो, एक डिव्हाइस हा डेटा ट्रान्समिट करत राहतो. रिसिव्हर ज्यावेळी अवेलेबल होईल त्यावेळी तो रिसिव्ह करायला चालू होईल. अदरवाईज जो काही मास्टरने आधी पाठवलेला डेटा असतो ट्रान्समिटरने, दॅट विल गेट लॉस्ट, राईट? बट हिअर इट हॅपन्स लाईक इन UART कम्युनिकेशन. When master initialize the communication, slave becomes ready to receive the data. So data loss is prevented in a UART communication. So whenever master initialize the communication, master gets synchronized with slave device, data loss is prevented in UART communication, right? So I hope it is clear. And drawback of both those UART and UART technology, can someone tell? What is the drawback? Okay, yeah, you will identify the drawback of those two technologies, but before that, let me put here I2C. What is this I2C? What is this I2C? Yesterday I told you, maybe in the last lecture I told you what is I2C. Okay. So let me tell you, I2C is inter-integrated circuit, and it is two-wire communication protocol. Let me show you how this I2C works. So the protocol I2C. This is very nice diagram to explain about the I2C. I hope this is visible. Is it visible?
Yes, sir.
Okay. So there are also master and slave device. As long as there is a synchronization is concerned, master device will initiate the clock. As I said, here you can see on the left hand side the master device, and on the right hand side the slave device, right? So master will initiate the clock and it will send that clock on a SCL pin. SCL designated here is to represent serial clock. SCL means serial clock, and master will generate the clock pulse and send it on SCL pin. Slave device will receive that clock pulse on SCL pin, right? So this is how the synchronization between those two devices is established. After that, SDA. SDA is the pin used by master and slave devices, and it is designated to represent the serial data, right? Serial data input output means what? When master want to transmit a data, it will send it on SDA pin, right? And slave will receive it on SDA line only. When slave want to transmit a data, he will have to wait till master completes its transmission. Once the master completes the transmission, uh, then slave can transmit the data on the same pin, on the same line, right? So what will happen? So at a time, this data transfer from master and slave, master to slave and slave to master is not possible in this case, because both the devices share a common line for data transfer. So what is the drawback of this one? Drawback of this one is it's a simplex communication. So sorry, it is half duplex communication, one at a time. Only one device can transmit a data at a time. So master, when it completes data transmission, slave will transmit the data after that. So this is how this I2C works, right? So this is two-wire communication. So if you proceed further, next is SPI, serial peripheral interface. Now, the whatever drawback you can observe it here for I2C will be rectified in SPI. Okay, let me check where is SPI communication. Okay, yeah, it is here. Okay. We will see with reference to this. I hope this is visible. Right, so this is SPI communication. In SPI communication, we have basically three lines and one additional line to select the chip. So chip select will decide which slave is to be selected for data transfer, right? And after that, we have SCLK. This is basically a serial clock transmitted by master device. And in addition to those, we have these two different lines for data transmission and reception. So on the master device, you may find it is like MOSI, stands for this MOSI. Okay, some different names are there actually. Let me check on another device. SDO and SDI is to be there. Yes, it is there. Right. So this is SPI controller and other peripheral. Controller means your master device. Peripheral means slave device. Now, this, as I said, chip select pin is additionally provided to decide the slave to be where to be communicated. Now, this master device generates a clock, and it is shared on pin called as a SCK. SCK stands for serial clock. So master device shares this clock on this SCK pin. After that, we have two pins, dedicated pins for serial data transfer, and another one is for serial data reception. So if this master device want to transmit the data, it will make use of SDO. SDO stands for serial data output. At the same time, this slave device will receive this data on SDI. SDI stands for serial data input. Now, if this slave device want to transmit something to the master device at the same time, then this slave device can make use of SDO, which is treated as serial data output for this slave device, and this master device will receive it on SDI, that is serial data input. So whatever drawback of that I2C was there, means what, at a time data transfer possible nahi I2C मध्ये, म्हणजे टू अँड फ्रो डेटा ट्रान्सफर वॉज नॉट पॉसिबल विथ I2C, but the drawback is rectified here in SPI. To and fro data transmission, which is actually a synchronous communication, is possible in SPI as well, right? So most preferably we have this SPI kind of thing in everywhere wherever we talk about wireless communication, right? So this comes SPI. So can someone guess what is next? Next is the one which every one of you is using is USB. USB stands for Universal Serial Bus. Okay, where I can get the protocol diagram. Okay, this way we can understand data plus, data minus. Okay. Okay, let me tell you what is there in USB actually. In USB you have let us show. Yeah. So if you could find this on the this diagram, you may find pin number 1 is positive. That means VCC. Pin number 4 is ground, right? Pin number 4, and pin number 2 and 3 represent D plus and D minus. So that simply means data to and fro. Data is going, data is coming, right? So the data transmitter, transmission, data reception. So this is very simple form of USB. Very simple form of communication technique adopted almost everywhere in the almost every part of world is using this USB. Now I want the reason why USB is preferred. Why USB is preferred? Everywhere USB is preferred, but I want to know what is the reason. I told you the pinout, how the USB communication happens. It carries VCC, it carries ground, it carries data plus, it carries data minus. Why USB is preferred? मला सांगा. माऊस वापरतायत तुम्ही कम्प्युटर सोबत कनेक्ट करून, का तुम्ही SPI वापरत नाही? का तुम्ही I2C वापरत नाही? का UART वापरत नाही? का तुम्ही UART वापरत नाही? Any reason? Why USB? व्हाय USB इज प्रेफर्ड एव्हरीवेअर. बघा, USB कुठं कुठं वापरताय तुम्ही? मोबाईल चार्जिंग करण्यासाठी USB वापरताय, बरोबर? ऑफकोर्स USB टू मिनी USB कन्वर्ट करून येतं, बट इट इज बेसिकली बेस्ड ऑन USB कम्युनिकेशन. त्यानंतर तुमचा प्रिंटर असेल, कोणताही कम्प्युटर पेरिफेरल असेल, इट इज बेस्ड ऑन USB ओनली. Let it be printer, keyboard, mouse, right? So it can be anything. It is used in a USB manner. Why? What is the reason? This could be a question in interviews, right? Why USB is preferred? Why not SPI, I2C, etc.? Just try to understand the significance. माझा आवाज पोहोचतोय ना सर्वांपर्यंत?
येस सर.
ओके. मी प्रश्न काय विचारला होता की यूएसबीच का आपण प्रेफर करतो, I2C, SPI का प्रेफर करत नाही? तर आता मी परत एकदा त्याच डायग्रामकडे जातो जिथं मी तुम्हाला दाखवलं होता. प्लस साइन इट इंडिकेट्स VCC, मायनस साइन इट इंडिकेट्स ग्राउंड. त्यामध्येच परत हा D प्लस D मायनस आहे, म्हणजेच काय, डेटा ट्रान्समिशन अँड रिसेप्शन. आता याच्यामध्ये होतं काय लक्षात घ्या, जर तुम्ही इथे SPI वापरायचा ठरवला, मग सपोज माऊस अँड कीबोर्ड असेल, mouse and keyboard. Imagine the situation, you are interfacing your mouse and keyboard with SPI or I2C. आता तुम्ही SPI, I2C सगळं बघितलं, UART बघितलं, तर त्यामध्ये कुठेही तुम्हाला पॉवर सप्लाय कनेक्टेड दिसला का? नाही दिसला. कुठेही पॉवर सप्लाय दिसला नाही. फॉर एक्झाम्पल, आता हा जर मी I2C मध्ये परत गेलो, इथला हा डिव्हाइस तुम्हाला दाखवला, ठीक आहे. ह्या I2C मध्ये आता अज्युम करा मास्टर म्हणजे तुमचा कम्प्युटर आहे आणि स्लेव्ह म्हणजे तुमचा माऊस आहे, ठीक आहे. डेटा ट्रान्सफर होतोय, ओके. पण व्हॉट अबाउट पॉवर ऑफ स्लेव्ह डिव्हाइस? स्लेव्ह डिव्हाइसला पॉवर सप्लाय सेपरेट डिझाईन करावं लागेल, सेपरेट त्याचा त्याला तुम्हाला ट्रान्सफॉर्मर, परत रेक्टिफायर, त्याचा व्होल्टेज रेग्युलेटर, फिल्टर सेपरेट डिझाईन करावं लागते, ठीक आहे. What will happen if I get the power from master itself, right? So this is what USB, this is how the USB is invented, and this is why the USB is popular. कारण त्याला जी लागणारी पॉवर असते इंटरनल ऑपरेशनसाठी, ती सगळी पॉवर तो मास्टर डिव्हाइस कडून घेतो, ठीक आहे. जर मला कीबोर्ड इंटरफेस करायचा असेल SPI माध्यमातून, SPI मधून तर पॉवर भेटणार नाही, SPI मधून मला मास्टर कडून पॉवर भेटणार नाही. सो इमॅजिन द सिच्युएशन, यू आर हॅव्हिंग अ कीबोर्ड विथ सेपरेट पॉवर सप्लाय, विथ सेपरेट अडॅप्टर. जसा तुम्हाला हे लॅपटॉप किंवा कम्प्युटर ऑपरेट करण्यासाठी जो सेपरेट अडॅप्टर येतो, 12 वोल्ट चार्जर किंवा SMPS वगैरे, त्या पद्धतीने तुम्हाला एक सेपरेट SMPS दिला जाईल आणि त्या SMPSनी तुम्ही तो कीबोर्ड ऑपरेट करायचा. इज इट फिजिबल? नो, इट्स नॉट फिजिबल. बेटर टू गेट द पॉवर फ्रॉम मास्टर डिव्हाइस ओनली. म्हणजेच जो CPU आहे त्याच्यातूनच पार्ट ऑफ दॅट पॉवर यू कॅन युटिलाइज फॉर ऑपरेटिंग विथ स्लेव्ह डिव्हाइस, राईट? दिस इज व्हाय USB इज व्हेरी मच पॉप्युलर अँड इट इज युनिव्हर्सली ऍक्सेप्टेड. त्याला सेपरेट पॉवर द्यायची गरज नाही. जी मास्टर कडून जसा क्लॉक येणार आहे त्याच पद्धतीने तुम्ही त्याच्याकडून हे घ्यायचं सप्लाय, right? So that you can have that slave device operational. I hope it is clear why USB is so much popular. Is it clear?
Yes, sir.
येस सर.
हा. तुम्ही आणखी एक एक्झाम्पल घेऊन विचार करू शकता की आधी जे मोबाईल फोन्स यायचे त्यामध्ये कसं असायचं, आधी त्याला सेपरेट सॉकेट फॉर पॉवर सप्लाय, सेपरेट सॉकेट फॉर डेटा ट्रान्सफर असं असायचं. लाईक सोनी इरिक्सन वगैरे त्यांचे त्या जनरेशनचे मॉडेल होते तसे, ज्याच्यामध्ये पॉवर सप्लाय वेगळा असायचा, वेगळ्या ठिकाणी कनेक्ट करावा लागायचा, डेटा ट्रान्सफरसाठी वेगळा केबल यायचा, राईट? So when everything is merged with USB, the things are getting simplified. म्हणजे त्याच सॉकेट मधून तुम्ही पॉवर सप्लाय किंवा बॅटरी चार्ज करू शकता, त्याच पॉवर सॉकेट मधून तुम्ही डेटा ट्रान्सफर करू शकता, ठीक आहे. Right. So this is why USB is important and USB is universally accepted. Anything is missing from communication system? Right. So if not, we will proceed further. What is this? Cloud. So this is the cloud architecture, cloud service model. This is how cloud works in every service industry. Right, I told you what is cloud. Cloud is a actually a virtual pool of data storage where every individual can subscribe and use the storage space. Right. So cloud is a model of computer data storage in which digital data is stored in logical pools. Right. So the physically storage spans multiple servers, sometimes in multiple locations. म्हणजे जगातल्या कुठल्याही पार्ट मध्ये तो क्लाउड सर्व्हर असू शकतो. राईट. देन the physical environment is typically owned by managed or hosting company. मग ते जे फिजिकल एन्व्हायरमेंट किंवा इन्फ्रास्ट्रक्चर असेल त्याची जी कंपनी आहे ती होस्ट करणार आणि त्यांनी ते सर्व्हर्स मॅनेज करायचे असतात. राईट. सो द क्लाउड storage cloud service provider, or you can say cloud storage provider, are responsible for keeping the data available and accessible and the physical environment protected and running. So these are the responsibilities have to be borne by that cloud service provider. मग तुम्हाला जर कोणी क्वेश्चन विचारला what would be the roles of cloud service provider, so let me repeat, they have to keep the data available all the time, it has to be accessible, then you have to keep that environment or keep that server protected and running all the time. So these are the roles of cloud service provider. Then people and organization who buy or lease that storage from that service provider to store the data, to store the user information, to store the organization's data, or to store the application data. Right. So people buy or lease the storage. तुम्ही ते विकत घेऊ शकता किंवा तुम्ही ते भाड्याने किंवा सबस्क्राईब करू शकता. Right. So cloud storage service providers may be accessed through cloud computing service or a web service application like API, or by application that use APIs such as cloud desktop storage. It may be a cloud storage or gateway. Right. So with that, let me tell you a little history of cloud. Then we will proceed to understand the architecture which is shown to you. History. Actually, the first cloud storage or the concept was invented by ARPANET. What is that ARPANET? Advanced Research Project Agency for this networking. Right. So cloud computing is invented by Joseph Carl. Name of cloud inventor is Joseph Carl. Keep it in mind. In 1960s, cloud was invented by Joseph Carl, who was working with this ARPANET. Then in 1983, CompServe was offered. 1983, CompServe was the service offered by this. CompServe is the service offered to the users, and it provided very small amount of disk space that could be used to store any files they choose to upload. म्हणजे छोट्या छोट्या एक्सेल फाईल्स असतील, एकदम लहान साईजच्या किलोबाइट्स मध्ये स्टोरेज प्रोव्हाइड केला गेला. Then in 1993, AT&T started a personal link. AT&T नी स्वतःचा क्लाउड सर्व्हर स्टार्ट केला. त्यानंतर फाइल्स एनिव्हेअर या नावाचा एक क्लाउड स्टोरेज सर्व्हिस चालू झाली, ती होती 1999 मध्ये. अँड फायनली Amazon get entered into this service area, and Amazon introduced AWS, right? AWS S3, first service cloud service provided by Amazon in 2006, and they provide a storage. They become a huge storage supplier. So this is the history of cloud service, or you can say cloud hosting services. Now, let us understand how this architecture works here. You can see the client side infrastructure. Client side infrastructure म्हणजे this is what you can see from client end. You can only see the internet. तुम्ही फक्त इंटरनेट बघू शकता. बॅक एंडला काय काय होतं. So this is the block. These are the blocks involved in back end. At the back end, you have different layers, which forms this layered architecture for cloud, which involves management. Then it may have application, service layer, storage, and security. So these are the 5 layers operates at the back end. मग या प्रत्येक लेअरचा वेगवेगळी फंक्शनॅलिटी आहे. ऍप्लिकेशन प्रोव्हाइड्स द सर्व्हिसेस, right? So services and subscription is stored in service layer. So actual storage which holds the data, and on the management side it manages all the security keys like login credentials are managed by management layer. That means suppose Ashish Jadhav is subscribed to 1 GB data storage space, and that too of what category, like he is allowed to store the data files, documents, he is allowed to store the music files, he is allowed to store the video files, right? So all this information and login credentials are managed by management layer. And security provides the authentication and the data secrecy. It maintains the data secrecy and it avoids the false play with data. That means invalid or data infringement is blocked here at a security layer. So these are the different layers works at the back end as far as cloud architecture is concerned. And at the client side, what you see is only the internet. So whatever data you are putting, whatever data you are storing on a cloud, that will go through the internet, and whatever data you are accessing from cloud, that comes from internet, right? You cannot see anything beyond that, right? So as a part of general knowledge, can you tell me where is the location of Gmail server? Can you tell me the location of Gmail server? Right, so you can easily Google it. As far as my knowledge is concerned, Gmail server located at California, and as far as WhatsApp server, initially it was there in the US only, and after that they have shifted when the user density is increased. WhatsApp server is in Hyderabad or maybe in Vijayawada. I don't know exactly, but it is there in the India, right? So, if you could calculate the distance between the cloud server of Gmail and the WhatsApp, you can find the WhatsApp server is nearer to you, right? Of course, the propagation delay is involved, so that's why the reason. This is the reason why you get the notification from WhatsApp immediately, right? So, if you compare the delay of notification, you get the notification on WhatsApp immediately if you compare it with the other things like Telegram and all that, Gmail or other Facebook notifications, right? So this is how the thing works. You are able to see the internet only. You cannot predict the thing, the photo that you have set as a WhatsApp DP. Actually, it may be located somewhere in the Brazil, or it may be in Africa. Whatever photos you are sending to your friend, you cannot tell where exactly they are getting stored. म्हणजेच काय, जर मी एखादी फाईल तुमच्याशी शेअर केली, सपोज इफ आय शेअर सम व्हिडिओ or let's say some image with you, I don't know exact location of that image. It may be stored in California, it may be in Brazil, it may be Washington, it may be anywhere on the anywhere geographically. If you consider, it may be present anywhere on the geographical this globe, you can say. Right, I hope it is clear how the cloud works. These are the application domains. Now I want you to note down those 3 application areas for Yeah, I want you to find the applications from those three domains. So these are the application domains for IoT application. So I hope you have noted down. Please note down those 3 points, and we will have a discussion on this in the next lecture. I want some input from your side. Everyone should contribute one application in those IoT application area, right? So note down those 3 points: wearable, smartwatch. Second one is smart home, and third one is smart cities. Each one of you should come up with at least one application in every domain. Is it clear? Have you noted those 3 points?
Yes, sir.
Okay. So wearable smartwatch, then second one is smart home, and third one is smart cities. And this is the last point of our topic that we will discuss in the next lecture. So everyone should come up with one application in every domain. So apart from that, if you find some applications, you are always welcome. Right? So if you have any doubt, you can ask me now. If you don't have any doubt, if you have mentioned your roll number in the chat box, well, I have something for you. Once we complete this, okay, we will share this MCQ part with you. Okay, let me tell you how to access the study material link. I hope all of you have received one link from your CC called as study material. If not, you ask madam. Okay, this one. Faculty diary with material. I hope this is visible. Okay, so on the first page you will see the timetable, and maybe here IoT A division, right? So if you go here, you will find this study material, right? So on the left hand side you can find the number of lecture and at what time it has been taken, and name of point which have been covered. But the thing which you may like is video lecture. Whatever lectures we are conducting, they are being stored on Google server, right? And we are Google Drive, in fact, and we are sharing those links here. So 4 लेक्चर्स झाले, 4 लेक्चर्सच्या लिंक मी इथे शेअर केलेले आहेत. ठीक आहे. त्यानंतर नेक्स्ट इम्पॉर्टंट अँड इंटरेस्टिंग थिंग इज द हँड रिटन नोट्स. सो इफ I click on this, you will be able to open the PDF file of that handwritten notes. Right? So this is introduction to IoT, all the definition part, then all the examples that we have discussed. Right? So this is what you might have seen this. Right? So street light and all that example. Just now we talked about reference model, then control unit, embedded system, what we have discussed about embedded system. Everything is covered here. Sensors, right? So all the theoretical part is taken into the consideration, and notes are prepared. So you can have you can have access to those data if you get the link from your CC. So if it is not shared by CC, please ask ma'am. Right. So if you have not received a link, please ask ma'am to share it. Right. So if you have any doubt, you can ask. Otherwise, you are allowed to leave if you have mentioned your roll number in the chat box.